Hi folks, I'm Chris Marshall with Woodworkers Journal magazine. Nearly every cabinet door made in a production shop these days is assembled with Cope and Stick corner joints, and I'm sure you've noticed them before. The corners of the frame fit together with these mirror opposite profiles, and they mesh perfectly. Plus they provide a huge surface area for glue, so they make a really strong joint. The good news is you can make Cope and Stick joints for your cabinet door frames that look every bit as professional as a millwork shop. All it takes is a router table, a set of Cope and Stick bits like this set from Freud, and a mid-size to full-size router in the 2 to 3 horsepower range. In this video, I'm going to walk you through the process. Let's start by taking a closer look at both halves of the joint. Here's a sample cabinet door style and rail. Now the sticking cutter cuts the majority of what you see. It creates this decorative profile along the full inside edge of both the stiles and the rails. The sticking cutter also cuts this groove along the inside edge, and that houses the door's panel or a piece of glass. Now the coping bit doesn't cut nearly as much wood as the sticking cutter does in a Cope and Stick joint, but what it does do is really important. It forms the mirror opposite profile to the sticking profile. It makes an inward-facing profile as well as this tongue, so the parts fit together, like this. Now you only use the coping cutter on the ends of the rails. Now Cope and Stick router bits are always sold as a match set because they have to fit together perfectly. This set that we're going to use to cut our cabinet door frame parts even includes this big panel raising bit for profiling the center panel. But there's another bit variation worth knowing about. Here's a single router bit that cuts both the coping and the sticking profiles. And what's handy about it is all you have to do is raise or lower it in your router table to switch from making coping profiles to sticking profiles. But either of these bit options will work great. If you've never used Cope and Stick bits before, figuring out which bit is which can be confusing because the bits are shaped opposite of the shapes they actually cut. So identifying them is really a matter of filling in the negative space. Now remember, I said that the sticking bit cuts the groove down the inside edges of the parts. Here's how I figure out which one the sticking bit is. I look for the cutter that has these small saw blade shaped cutters on top. That's what cuts this groove. Once I've identified the sticking cutter, well, the coping cutter is the other one. I know that it sounds silly, but every time I route Cope and Stick joints, I study these bits carefully first to make sure I'm using the right bit at the right time. If I choose the wrong bit, my door frame parts will be ruined because these bits are not interchangeable. And here's something else to keep in mind. We're used to looking at cabinet doors with the profile facing the front. But on Cope and Stick bits, that profile cutter is on the bottom of the bit, not on the top. So whenever you're routing Cope and Stick joints on the router table, always, always, always face your best face of the stock down. The back face of your door frame parts is always up. Now that we've taken a really close look at these bits, let's go ahead and cut some door frame parts. Start the process by jointing, planing, and cutting your door rails and stiles carefully. It's important to begin with flat, square pieces that are the same thickness. Any warping will lead to twisted cabinet doors that won't close flat, so use your best straight grain stock. And do yourself a favor, make a couple of test pieces too. We're going to start by coping the ends of the rails first, so go ahead and mount your coping cutter in your router table now. Why start with the coping cuts? Well, we could route the sticking profile on the inside edges of the rails, but then those edges would be shaped. And coping cuts are cross-grain cuts. If we followed with the coping cuts, one of the inside corners of these profiled edges would be likely to splinter out. We don't want that to happen. So the best course of action to take is to do your coping on the rails while all the edges are still flat. With the bit set high, slide your router table fence up to it and align the rim of the bearing that's inside the bit so it's flush with the faces of the fence. Check it with the ruler and lock the fence. So now we need to set the bit height for the coping cutter. And remember, the coping cutter cuts this tongue, but it's not flush with the back faces of the workpiece. It needs a little shoulder behind it. So I lower my coping cutter to cut a shoulder that's about 1/8 of an inch deep. So since coping cuts are cross-grain cuts on the ends of these narrow rails, we're going to have to back them up carefully from behind in order to make them safely. Now you could use a miter gauge with a sacrificial fence installed if you have one, or you could just use a square piece of scrap like I'm going to do. The goal here is to stabilize the workpiece from behind so that it doesn't rock back and forth as you push it through the bit, and to help minimize tear out on the back side. Set your router to a medium-high speed and, using one of the test rails you made, route across one end to check your bit height setting. So that first coping test cut turned out pretty well. I've got about 1/8 of an inch of shoulder behind the tongue, and the cut looks balanced through the thickness of the part. So I'm going to go ahead and coat my 2 door rails, but if you have to make some bit height adjustments, now is the time to do it and make more test cuts. When coping both ends of a rail, don't forget, the backs of the rail should be facing up. Route one end, turn the piece end for end, and cope the other end. If you stop to check your results after the first cut, be careful to not accidentally flip the workpiece over, or you'll have coped ends facing opposite directions. So that takes care of the coping process, and we can put that bit away. Now I've got the sticking cutter installed on the router table with the bearing on top lined up with my router fence faces. Here's how I adjust it for height. I set one of my coped workpieces next to the bit and raise or lower it until the groove cutters on top line up with the tongue of the rail. Try to get this as close as you can. You may need to spin the bit slowly around, as some sticking bit designs have several wings set at different heights to make the groove. Now, sticking cuts are long grain cuts made along the full length of the inside edges of the rails and stiles. And since these parts are narrow, I like to install a couple of feather boards on either side of the bit. Feather boards will keep the workpieces pressed tightly against the fence, and they'll make sure that my sticking cuts are consistently deep. Route the sticking profile along the edge of one of your test pieces so you can check the bit setting for accuracy. Use a push stick to guide the workpiece through the bit. So let's check our test cuts. Right out of the gate, that's a pretty good sticking cut. The goal is for the parts to mesh together completely and be flush with their faces. If you can feel a little bit of a ledge on the faces, raise or lower your sticking bit just a touch and make another test cut to fix it. Mine feels pretty good, so I think I'm ready to route my actual door frame parts. Mill the sticking profile along the inside edges of all 4 rails and stiles. And don't forget, back face up, always. And if you've worked carefully up to this point, it'll pay off now. Your cabinet door frame will fit together with airtight joints that are ready for glue up. But just as importantly, the door frame will lay flat. Cope and stick router bits really aren't that hard to use once you understand the cutters. And when you get them dialed in just right, you can build door frames as fast as you can run wood through the machine. So good luck with your door frame joinery, and thanks for watching.